A hyperbolic cooling tower stands 177.7 meters tall. The diameter of the top is 80 meters. At their closest, the sides of the tower are 50 meters apart. From the bottom up to the narrowest part is 100 meters. Find the equation that models the sides of the cooling tower. So as we look, here's a cooling tower, and if we kind of trace out the sides here, we can see this hyperbolic shape. And I'm going to go ahead and draw this down below so we can kind of get a sense of what information we have and kind of label it easier. So here is our cooling tower, and let's put in the pieces of information we have. It's 177.7 tall, so if we were to get this measurement, 177.7 meters tall. The diameter of the top, so all the way across the top here, let me actually put that in a different color so it will stand out. All the way across the top here is going to be 80 meters. And at the closest, the sides are 50 meters apart. So the closest would be right here, where we'll have the vertices of the hyperbola, and this distance is 50 meters. Then one last measurement from the bottom up to the narrowest part, so that would be right here, is 100 meters. Okay, so there's the information we have. So in looking here, and I marked our vertices, we're going to make an axis here that we're going to have the center right here at 0, 0. And so we'll put an axis here. So we can see that our transverse axis is along the x-axis and our center is at 0, 0. So that means our hyperbola is going to have x squared as the positive term, and then y squared as the negative term equal 1, and the h and k are 0 and 0. Now I can see from the center how far I would need to go to each vertex, because if you look at this picture, it's 50 all the way across. So this piece right here is going to be my A, and that's going to be half of 50, or 25. So if A is 25, then we know that underneath the x squared is A squared, which is going to be 625, which is 25 squared. Now I want to try and figure out what the B squared is, and I don't have that information, but there is some other information I do have that will lead me to get the B squared. I can figure out what this point is on the hyperbola, and if it's a point on the hyperbola, it makes the hyperbolic equation true, so I could plug that in for the x and the y and find the B squared. So let's figure out what that point is. So here's our origin down here at the center. All the way across the top, the diameter is 40, so from the y-axis over would be half of that, or 40. So our x value of our point is 40. Now let's figure out our y value of our point. Our y value of our point would be this distance right here from the x-axis up to the point. Well, the height of the whole thing was 177.7, and the height of this bottom piece was 100. So if we do 177.7 and subtract that bottom piece, we would have that y value of that point. So that's going to be 77.7. And now that I have a point on the hyperbola, I can plug that in this equation for the hyperbola, and I'll be able to find B squared. So the x from the point is 40, so I'm going to put in 40 squared over 625, minus the y from the point is 77.7. I'm going to square that, and that's over, I don't know, that's B squared equals 1. So the only thing I don't have in this equation is the B squared. So I'm going to solve this for B squared. First, I'm going to go ahead and square that 40, 1600 over 625. I'm going to move this 1 over so I can combine it, and I'm going to move this term over to the other side. So it's going to be 77.7 squared over b squared. Because it had the variable, I moved it over to the right, and it's now positive. Okay, so we can combine these. If this is a -1, so I can write 1 as 6/25. It's 625 over 625. So 1600 minus 625, that's going to be 975 over 625. And that will equal 77.7 squared over b squared. Now looking at that fraction on the left, I can easily see that 25 goes into both of them. So I'm going to reduce the fraction just to make it a little bit lower numbers to deal with. 25 will go in there 39 times, and 25 will go in there 25 times. So that fraction will reduce to 39/25 equals 77.7 squared. Now I'm going to clear this equation of fractions. And so in order to do that, I'm going to go ahead and move up here where I've got some room. So I'm going to have 39b squared is going to equal 77.7 squared times 25. Now my last step for getting b squared alone will be to divide by the 39. And now my b squared is going to equal this, so I'm going to get my calculator and put that in for b squared, and then I will go ahead and write it over in my equation here for b squared. And I'm going to round it to 2 decimal places. So putting that in the calculator, I get 3,870.06. And so here is the equation of the hyperbola that defines the sides of this cooling tower.